Okay, let's start the lecture. Today we discuss uniform continuity. Uniform continuity. First, we recall the definition of continuity. A function, a real valued function, in fact, a real valued function. A real valued function f is continuous at some point a belongs to R if given epsilon positive, there exists delta positive, such that mod of x minus a less than delta implies mod of f of x minus f of a is less than epsilon. So that's the definition. This delta in general depends on epsilon as well as this point, because we have chosen this point first, then for each epsilon positive there is a delta positive. So in general this delta, it depends on both epsilon as well as the point A, the chosen point A. So in general the number delta depends on both epsilon and a. Okay. So let's take the example where we can check this point, this epsilon. It depends on both. This as delta, it depends on both epsilon as well as on the point A. So let's take this example. So let's take this function f from R to R, defined by f of x is equal to x. Okay, so clearly this x, it's minus infinity less than x less than infinity, because x is in R. So minus infinity less than x less than infinity. Then we verify that. Then we verify that with if I choose epsilon for all epsilon, so with this epsilon, with this value of epsilon, with epsilon equals to 2, with epsilon is equal to 2, we have this mod of x minus a less than 1 by 2 implies mod of f of x minus f of a less than 2. So 2 is our epsilon. Then we verify that this, if this point A is equal to 1. So at this point A equal to 1, we have for if I choose epsilon equal to 2, then this holds. Mod of x minus a less than 1 by 2 implies mod of fx minus fe is less than 2. So your delta is actually 1 by 2. Okay, this is your delta. But we will see that this delta does not work. This 1 by 2 does not work for each point. it works for a equal to 1 by 2. This is true. Whenever x minus a is less than 1 by 2 implies mod of fx minus f of a less than 2 at if a is equal to 1. It's true. So let's verify this first. And then we see that this is not true for each a. In particular, if I choose a equal to 10, this does not hold. Mod of x minus a less than 1 by 2 doesn't imply that mod of fx minus fa less than 2. So that means I can say that for each epsilon positive, I cannot find a unique delta. I cannot find one delta such that mod of x minus a is less than 1 by 2 implies mod of fx minus fa less than 2 for both the values of a equal to 1 and a equal to 10. So in other words, I can say this delta, it depends on the point also. So I have to change this delta at that time. So let's now first verify this star. Okay, so this star, let's call it star. Okay, we verify this star. Okay, so we have mod of x minus is less than 1 by 2. Okay, so we have mod of x minus a, that's equal to here mod of x minus 1 is less than 1 by 2. This implies, what does it imply? It means that 1 minus 1 by 2. Okay, so this is 1 minus 1 by 2 is 1 here, and then 1 plus 1 by 2. Okay, this is 1 minus 1 by 2 less than x less than 1 plus 1 by 2. That means 1 by 2 less than x less than 3 by 2. Let's apply the square because I want to prove that mod of gx minus g of a, this should be less than 2. So that means I want this g of x is x square, so x square minus g of a is a square is 1. So I want this actually x square minus 1, this should be less than 2. So let's try to find out this. First x square, then I subtract minus 1 throughout. So by applying square we get 1 by 4 less than x square less than 9 by 4. Let's subtract 1 throughout. 1 by 4 minus 1 less than x square minus 1 less than 9 by 4 minus 1. So this means it's 1 minus 4, that's minus 3 by 4 less than x square, it's x square minus 1 square less than 9 minus 4 is 5 by 4. So this means minus 3 by 4, obviously minus 2 is less than minus 3 by 4. This is straightforward, and that's less than x square minus 1 square means g of x minus g of 1 less than 5 by 4, but 5 by 4 is less than 2, right? And this implies it's minus 2 less than, this is obviously g of x minus g of a. So a is 1, it's less than 2, so which means that mod of gx minus g of a is less than 2. So thus we have mod of x minus a less than 1 by 2 implies mod of fx minus g of x, g of x minus
fx was get.
Oh, fx. Let's see first. It's fx, right? It's fx. It's not gx. Okay. Okay. Thank you. It's your fx. Okay. Let's write fx here. Okay. Okay. This is f. Okay. F. This is f of x minus f of a, and here it's f of x, f of a less than 2. So for epsilon equal to 1 by 2, I can find delta equal to, for epsilon equal to 2, I can find delta equal to 1 by 2, such that this holds for if this a is 1 by, if a is 1, okay. So at this point a, for epsilon equal to 2, I have a delta, okay. But if I vary this point, if I choose a equal to 2, so this doesn't work here. So but if a equal to 10, then mod of x minus a less than 1 by 2, does it imply this mod of f of x minus f of a less than 2? So for this epsilon, I must choose two values of delta, one for a equal to 1 and the second for a equal to 10. So that means this delta, it depends on both epsilon as well as the point. So let's first calculate this, क्योंकि मुझे ये prove कर, this doesn't imply, this means that there is some point which satisfying this inequality mod of x minus a less than 1 by 2, but it does not satisfy this. At that point we don't have this inequality. So I must choose a point here in this range. I choose a point x naught such that mod of x naught minus a less than 1 by 2, but mod of f of x naught minus f of a is not less than 2. So that's what it means actually. This does not imply this. So implies means जो भी point आप इसमें लोगे जो इस inequality को satisfy करेगा, it should imply this inequality. But when you write this doesn't imply this, it means that हर किसी point के लिए नहीं, doesn't imply, हर किसी point के लिए true नहीं है. मतलब ये आपको हर किसी point के लिए verify नहीं करना है कि ये इसको imply नहीं करता. आपको सिर्फ एक point चाहिए जिसके लिए एक ऐसा point choose आपको करना है जो कि इस range में हो. मतलब रेंज का मतलब क्या है, जो इस इनइक्वालिटी को सेटिस्फाई करे, mod of x minus a less than 1 by 2 को. But at that point we don't have this inequality mod of fx minus fa less than 2. So for this I have to first find this range actually. ये range क्या है? What's this range? A is 10 here, so I can find this range. So let's first find this range. So we have mod of x minus a less than 1 by 2 implies mod of x minus 10 less than 1 by 2. So this means it's 10 minus 1 by 2 less than x less than 10 plus 1 by 2. Okay, so this I can write, it's 10 minus 1 by 2 means it is 9 3 by 4. Okay, 9 of 3 by 4, 9 plus 3 by 4. Okay, that is, it is actually 9.75. This is less than x and less than 10 of 1 by 2. 10 plus 1 by 2 can be written as like this. So let's choose a point in this range. So choose x naught is equal to 10 of 1 by 4. Okay, 10 plus 1 by 4. Let's see. Then this point satisfies this inequality. Then 9 3 by 4 is less than x naught is less than 10 1 by 2. तो ये इस रेंज में है, ये पॉइंट मतलब ये इस इनइक्वालिटी को सेटिस्फाई कर रहा है. mod of x minus c is less than 1 by 2, or that is you can say this mod of x naught minus a is less than 1 by 2 for a equal to 10. But we see that this doesn't hold. Mod of f of x naught minus f of a is not less than 2. So let's calculate this difference first. But mod of f of x naught,
वहाँ पे 9 2 by 4 हो गया ना कि 9 3 by 4.
okay, let's see it again. Oh, it's 1 by 2. It's not, I thought it's 1 by 4. Okay, it's 1 by 2. You're right. It's 9 1 by 2. Thank you. It's 9 1 by 2. Okay. Now let's see this. This is equal to mod of f of x naught minus f of 10 1 by 4 minus f of a minus f of 10. So that's equal to 10. Let's expand, right, in expanded form. It's 10 plus 1 by 4 whole square minus, so obviously it's positive because this thing is greater than this, 10 square, or you can put mod here. This is obviously 10 square plus twice AB, that's obviously 10 by 2, and check it, plus 1 by 4 square, that's 16, minus 10 square. Okay, this and this will go. It's 10 by 2 minus 5 plus 1 by 16, that's obviously greater than 2, it's not less than 2, it's not less than 2. So therefore the value of delta which you had taken 1 by 2 is good for a equal to 1 but not for a equal to 10. So therefore delta equal to 1 by 2, it works for what? For equal to 1 but not for equal to 10. At epsilon equal to 2, क्योंकि हर किसी एप्सिलॉन के लिए आपको डेल्टा मिलना चाहिए ना, तो इस एप्सिलॉन इक्वल टू 2 के लिए आपको डेल्टा मिला है, डेल्टा इक्वल टू 1 by 2 फॉर इक्वल टू 1, बट द सेम वैल्यू ऑफ डेल्टा डजंट वर्क. So but not for, okay, but not for equal to 10. But not for, but maybe there may be some other delta है ना, a equal to 10 के लिए कोई और डेल्टा होगा जो कि a equal to 1 के लिए भी काम करेगा, ऐसा भी हो सकता है. आपको मेरी बात समझ आ रही है? जैसे आपने a equal to 1 पॉइंट किया चूज और एप्सिलॉन को लिया आपने 2, ओके. तो कंटिन्यूटी का मतलब कि आप पहले पॉइंट चूज करते फिर आप कहते फॉर ईच एप्सिलॉन पॉजिटिव आई कैन फाइंड डेल्टा पॉजिटिव साइड दैट दिस एंड दैट होल्ड्स. So in particular, if I choose this point equal to 1 and if I choose positive number epsilon equal to 2, then obviously I have a delta equal to 1 by 2 satisfying the property of continuity. But if I vary the point, if I choose the point a equal to 10, this same delta does not work, this same delta. But I can choose different delta. I can choose say delta equal to say 1 by 100. Maybe that delta will work for both a equal to 1 or a equal to 10. Maybe that delta work for say 10 values, say 100 values. But the question is that can I choose delta positive such that delta works for all a's, जो भी a आप choose करोगे, and the answer is no for this particular function f of x equal to x square over the whole real line. So let's negate that. So we had to prove that we cannot find a unique delta for all a's. So for assume on contrary that there is a delta which works for each a, which works for each a. So in fact there is no delta, there is no delta positive such that there is no delta positive such that this holds. Mod of x minus a less than delta implies mod of f of x minus f of a less than say less than 2. Let's write 2 here, okay. यही 2 के लिए हम कर देंगे less than 2 for all a and r1. देखिए कंटिन्यूटी का मतलब क्या है. अगर हम कंटिन्यूटी एट अ पॉइंट डिस्कस करते हैं, हम पहले पॉइंट को चूज करते हैं. वी से अ फंक्शन इज कंटिन्यूअस एट ए इफ फॉर ईच एप्सिलॉन पॉजिटिव देयर इज डेल्टा सच दैट दिस होल्ड्स. अब यहाँ पर मैंने क्या किया, मैंने पॉइंट को बाद में लिया. एक्चुअली आई चेक द यूनिफॉर्मिटी. So in fact there is no delta positive. अगर suppose ऐसा delta होता, there is delta positive such that mod of x minus a less than delta implies mod of fx minus fa less than epsilon, every epsilon positive for each a in this domain R1, then I say that function is actually uniform continuous. Okay, the definition of uniform continuous function. But here I will prove that for this particular function this does not hold, so I don't have any delta positive with this property for epsilon equal to 2. So assume on contrary that there is delta. Assume on contrary that there exists delta positive such that mod of x minus a less than delta implies mod of f of x minus f of a less than 2 for all a in R1. or you can write R or R1, that's one and the same thing. Now so आप आपने डेल्टा चूज किया है, अब आपको डेल्टा मिल गया, साइड दिस होल्ड्स. ओके, डेल्टा अब आपके पास है. So now let's choose any point. Now this is true for each point. So now let's choose a positive number. Okay, इसके लिए भी true होगा ये. So whenever x minus a less than delta, then this should imply mod of fx minus fa less than epsilon less than 2. Okay, so this is true. So choose. अब हम ऐसा पॉइंट चूज करेंगे, ऐसा x हम चूज करेंगे जो इसको सेटिस्फाई करे, जो इसको सेटिस्फाई करे. अगर ऐसा x आपने चूज किया जो इस इनइक्वालिटी को सेटिस्फाई करे, अब क्योंकि आपने मान लिया कि ये डेल्टा आपके पास है, तो आपको ये मिलना चाहिए mod of fx minus fa less than 2 उस x के लिए. ऐसे सारे x's जो इसको सेटिस्फाई करे, mod of x minus a less than delta where is any point, we should have mod of fx minus fa less than 2 for all a in R1. So choose x is equal to, let's choose this point x which is equal to a plus delta by 2. Let's write here x naught. Then let's name it star. Then mod of x naught, what is this mod? This is equal to mod of a plus delta by 2 minus e, that's delta by 2, which is obviously less than delta. So that means mod of x naught minus e is less than delta. Now by star we must have, by star we must have this mod of f of x naught minus f of a is less than 2. Okay, so this means what's f of x naught is x naught square minus a square is less than 2. A is a positive number and x naught is a plus delta by 2, so this implies it's a is a positive number, a plus delta by 2 square minus a square, it's mod. Okay, so we don't mod here because this number is greater than this, as we are adding delta by 2, delta is a positive number. So let's expand this now. What's this? Or don't need to expand. Let's if I expand it, it will be a square plus delta square by 2 plus 2 is a delta. I can expand it also, so without using the mod here, so it's a square plus twice a delta, that's just a delta, twice a times delta by 2, it's just a delta plus delta square divided by 4 minus a square is less than 2. A square and a square will go. Okay, it's a delta plus delta square by 4 is less than 2. Now this means, now this a delta it's less than a delta plus. Now this a delta it's less than a delta plus delta square by 4, because you are adding a positive number, but this thing is less than 2. So which means that your a delta is less than 2 for all a positive. This is true for all a, because there is any positive number. So that is, we have a delta is less than 2 for all a positive. Is it true? This is true for all a positive. डेल्टा तो यूनिक आपको मिला हर किसी ए के लिए. सो इन पर्टिकुलर अगर आप ए को चूज करोगे, क्या इन पर्टिकुलर choose a equal to say 2 by delta, because 2 by delta is a positive number, then 2 by delta times delta is less than 2, which means 2 is less than 2. Introduction. As required. So we don't have a unique delta which works for each point. So so in fact this function is continuous. In fact this f of x equal to x square where minus infinity less than x is continuous. Yes, yes, any problem? So this function is a continuous function, but but we don't have delta which works for each point. Okay, so that delta depends on both phi as well as the epsilon positive, both the things. And suppose we have for some function we have a delta which works for each point, then we call such function is uniform continuous. Okay, so this function is not uniform continuous. F of x equal to x square where minus infinity less than x less than infinity, this is not uniform continuous. So let's now define the uniform continuous function. So first, if a continuous function is such that if a continuous function is such that given epsilon positive, we can choose delta. We can choose delta positive so that this delta depends only on epsilon. Depends only on epsilon, but not on a. इस पॉइंट पर डिपेंड ना करे, सिर्फ एप्सिलॉन पर डिपेंड करे, then we see that the function is uniform continuous. Then we see that the function is uniform continuous. Now अब इसकी फॉर्मल डेफिनेशन क्या है यूनिफॉर्म कंटिन्यूस, और हम इसको मैथमेटिकली लिखेंगे यूनिफॉर्म कंटिन्यूस. So let's write the definition here. We define it in terms of matrix space, okay, for general matrix spaces. So let's take two matrix spaces. Let x with d1, okay, and y with d2 be matrix spaces. If f from x to y, if f is a function from x to y, we say that f is uniform continuous. We say that f is uniform continuous on not on this space X, not at a particular point. If अब हम पॉइंट की बात करेंगे ही नहीं ना. If given epsilon positive, there exists delta positive. So that's a formal definition of uniform continuous. There is delta positive such that, अब वही जो मैंने कहा था क्या, continuity at a point में हम क्या करते हैं, पहली पॉइंट को we say the function is continuous at that point if given in epsilon positive there is delta. But here we are talking about uniform continuity, so we say not at a point, we say on whole space if given in epsilon positive there exists delta positive such that we have this with this d1 of say x and a less than delta implies d2 of their images f of x f of a less than epsilon for all a in the space is here x, okay, for all a in x. So this delta depends only on epsilon, okay. So let's in particular if we have this, if both the spaces are real spaces, in particular if this x d1 is the real line and y d2 is the same real line, then this f, the real valued function, then f from R to R is uniformly continuous, is uniformly continuous. A particular case हमने लिया अगर दोनों मैट्रिक्स स्पेसेस रियल लाइन होगी on R if given epsilon positive there exists delta positive such that mod of x minus a less than delta implies mod of f of x minus f of a is less than epsilon for any point a in R. Okay, this is it. So therefore f of x equals to x square, this function minus infinity less than x less than infinity is not uniformly continuous. This function is not uniformly continuous. But it's continuous, okay? Continuous है but not uniform continuous. So one thing is clear that every function which is uniformly continuous is obviously continuous. So that exercise for you. So let's take two matrices. We let x d1 and y d2 be matrix spaces. Okay, if f from x to y is uniformly continuous, then show that f is continuous on x, or f is continuous means continuous on x, then show that f is continuous. So every uniformly continuous function is continuous. अब आपने एक थ्योरम की होगी एनालिसिस में, a continuous function on closed interval is uniformly continuous if f from closed interval ab to r is continuous या फिर से कीजिए, then show that f is uniformly continuous, then show that f is uniformly continuous. Every continuous function on closed interval is uniformly continuous, ये आपको करना है. तो इसका हम जनरल केस करेंगे आगे या at the end of this lecture series. So in which we will show that every continuous function on compact set is uniformly continuous. This is a particular example of compact set closed interval. Okay, तो उसका जनरल केस हम आगे करें. So you will do this one. If f is continuous on closed interval ab, then it's always uniformly continuous.
सर इस पेज पे आर को यूजुअल मैट्रिक के साथ हम ले रहे हैं.
या यूजुअल मैट्रिक, ऑलवेज यूजुअल मैट्रिक. अगर मैट्रिक यहाँ पर गिवन नहीं होगा आर पर, सो इट इज ऑलवेज टेकन टू बी यूजुअल मैट्रिक हियर whenever we don't have metric. ओके, तो अगर डिफरेंट होगा मैट्रिक, वहाँ पर हम मेंशन करेंगे इसको मैट्रिक क्या है. So this was about uniform, continuous and continuous. So we have one more example of continuous function which is not uniformly continuous, so that you will do again yourself. This is the function defined by the function f, which is defined by f of x equal to 1 over x. दिस फंक्शन शायद ये आपने किसी जगह डिस्कस की भी होगी. 0 लेस देन x लेस आर इक्वल टू 1. दिस फंक्शन इज कंटिन्यूअस. आपको प्रूव करना है ये जो फंक्शन है ना, ये कंटिन्यूअस. दैट्स वेरी सिंपल. इज कंटिन्यूअस. कंटिन्यूअस मीन्स आपको पहले पॉइंट चूज करना है और उस पॉइंट पर आपको प्रूव करना है ये कंटिन्यूअस है. ओके, सो इज कंटिन्यूअस ऑन दिस इंटरवल open 0 1 closed. Show that this function is continuous. Okay, the function this defined by this. Show that here. Show that the function which is f defined by is continuous on this, but not uniformly continuous. यूनिफॉर्मली कंटिन्यूस नहीं है ये. ओके, also verify that there is no way to define f of 0. There is no way to define f of 0. f of 0 आप डिफाइन कर सकते, देखिए इन जनरल तो आप कर सकते हो f of a को डिफाइन. You take f of a equal to say 5 6 7, but here he says there is no way to define f of 0 so that the function will become continuous at 0 also. At 0 also, so that the resulting extension, क्योंकि तो इसकी एक्सटेंशन होगी ना, कि ये f जो है ना गिवन, ये इस पर डिफाइन है. ओपन 0 1 क्लोज. 0 पर ये डिफाइन नहीं है, अब आपने 0 पर भी डिफाइन, सो इट इज नाउ x some sort of extension of f. So that the extension, so that the resulting extension is continuous is continuous on the closed interval 0 1. You can't do this. Okay, you can't define f of 0 so that it will become continuous at 0 in general, in simple English you can say. आप एफ ऑफ 0 को ऐसा डिफाइन नहीं कर सकते हो ताकि ये 0 पर कंटिन्यू, बाकी हर किसी पॉइंट पर ये कंटिन्यूस है जो इस रेंज में है 0 से लेकर 1 तक, बट इट्स नॉट डिफाइंड एट 0. मगर क्वेश्चन ये कि क्या हम 0 पर इसको ऐसा डिफाइन कर सकेंगे ताकि ये 0 पर भी कंटिन्यूस बन जाए, जिसको हम कहते हैं ना रिमूवेबल कंटिन्यूटी, डिसकंटिन्यूटी. सो इट्स नॉट ऑफ दैट टाइप. ओके, so there are functions where the functions are not defined at 0, but still we can define function the function at 0 so that it will become continuous at 0. Like if you take this example of sin x by x, suppose let's define this function on the open 0 and closed 1. Then we take the value of f0 to be 0, हम f of 0 का value 0 लेंगे and the function will become continuous at 0 also. तो कुछ एग्जाम्पल्स ऐसी है, बट कुछ एग्जाम्पल्स इस टाइप की भी है जहाँ पर जो है गिवन फंक्शन वो 0 पर डिफाइन नहीं है, मगर आप एफ ऑफ 0 को ऐसा कोई वैल्यू असाइन नहीं कर सकते सो दैट द रिजल्टिंग फंक्शन विल बिकम कंटिन्यूअस. सो यू कांट डू दैट. फॉर एग्जाम्पल दिस. अब क्वेश्चन ये है कि ये हम कब कर सकते हैं, व्हेन वी कैन डू दिस, व्हेन वी कैन डू. एंड यू कैन सी दैट अगर आप यहाँ पर देखना चाहोगे, अगर आप इसका क्लोजर लेना चाहोगे, दिस इज द क्लोज इंटरवल 0 1 है ना, इसका क्लोजर इसके बराबर है. तो इस पर तो फंक्शन कंटिन्यूअस है 0 1 पर, मगर इसके क्लोजर पर कंटिन्यूअस नहीं. हम इसको इसके क्लोजर पर एक्सटेंड नहीं कर सकते हैं विद प्रिजर्विंग द कंटिन्यूटी. एक्सटेंड तो कर सकते हैं बट विद द कंडीशन दैट जो इसकी गिवन प्रॉपर्टी मीन्स क्योंकि ये कंटिन्यूअस है, इस पर इस कंटिन्यूटी को हम प्रिजर्व नहीं कर सकते टू इट्स क्लोजर. इस एग्जाम्पल. So if f is a function, if we have a matrix space x and y, okay, if we have a subset a of x such that a closure is x and f is a continuous function from a to y, we cannot extend this function to whole x. हम इसको extend नहीं कर, this cannot be done. अगर given function continuous है a से लेकर y तक और a dense है x में, मतलब a closure x के बराबर है, but we don't have any extension, we can't extend f to whole space with preserving of this continuity. We can't do this. And when we do this, the question is when we do this. In general we cannot do this. अगर function continuous होगी we can't extend it. And the question is when we can do this. And the answer is if the function is uniform continuous. अगर ये जो फंक्शन होगी ना, अगर ये इस a पर यूनिफॉर्म कंटिन्यूअस होगी, देन वी कैन डिफाइन इट ऑन होल स्पेस एंड द न्यू फंक्शन, न्यू एक्सटेंशन विल बी आल्सो यूनिफॉर्म कंटिन्यूअस. आपको बात समझ आ गई? हम इसको कब कर सकते हैं, वो हमारे पास थ्योरम है एक्सटेंशन ऑफ यूनिफॉर्म कंटिन्यूअस फंक्शंस. सो इसका हम प्रूफ लिखेंगे आगे. सो दिस कैन बी डन इफ द फंक्शन इज यूनिफॉर्मली कंटिन्यूअस ऑन द गिवन स्पेस. That is our next theorem and we'll do it in next lecture. But here is one more example. That's this. If we have a function g of x, you know these exercises, it's a sine of 1 over x, and here x is not equal to 0. It's true for it is defined for any real number, है ना, हर किसी real number पर ये define है except at x equal to 0. But the question is, can we assign a value to the function g at 0 so that the new function जो कि अब 0 पर भी define है, so that the new function will become continuous? The answer is again no. As you can see this minus infinity to 0 union 0 to infinity, इसका जो ये आपका a set है, okay? और अगर आप a closure देखोगे, that's whole real line. A पर function continuous, this function is continuous, but not on a closure. We cannot assign the value to 0 to g of 0 so that this function will become continuous on the whole space. That's not the case here. So again the reason. तो अगर इस टाइप देखिए, यहाँ पर आप डायरेक्टली ये भी कैलकुलेट कर सकते हैं कि इस टाइप की फंक्शन जो है ये यूनिफॉर्मली कंटिन्यूअस नहीं है. दे आर नॉट यूनिफॉर्मली कंटिन्यूअस, क्योंकि अगर ये यूनिफॉर्मली कंटिन्यूअस होती then you can do this, then you can extend this uniformly to the whole space. So this is another example. We cannot define g of 0 so that the resulting extension will become continuous on whole space, and the reason is this, because the limit x approach to 0 sin of 1 by x does not exist. ये जो लिमिट है ना ये एग्जिस्ट नहीं हो रहा है. कोई आप में से आंसर दे सकता है व्हाई दिस लिमिट डज नॉट एग्जिस्ट? क्योंकि इसके लिए है ना, अगर देखिए फंक्शन ही है कि इसके लिए तो ओबियसली ये है कि आपका जो ये लिमिट है दिस शुड एग्जिस्ट एंड दिस शुड इक्वल टू द वैल्यू ऑफ द फंक्शन एट 0. दिस शुड बी इक्वल टू g ऑफ 0. तो सबसे पहले तो कंडीशन है कि लिमिट एग्जिस्ट होना चाहिए. तो इसका आंसर ये है कि इसका लिमिट एक्चुअली एग्जिस्टेड नहीं हो रहा है 0 पर. तो 0 पर इसका लिमिट क्यों एग्जिस्ट नहीं हो रहा है? Anybody can answer this question? Yes?
क्योंकि 1 by x का लिमिट नहीं एग्जिस्ट हो रहा है 0.
Okay, 1 by x का लिमिट x नहीं होगा which is equal to infinity. Okay, that's right. So in the external complex में it exists, but the here तो ये तो हम उस पर भी लॉजिक कर सकते अप्लाई कर 1 by x पर भी, but there we don't apply this logic. 1 by x इसका लिमिट जो है वो इन्फिनिटी आ रहा है. so actually यहाँ पर जो है ना लिमिट, it actually oscillates this value. It's always some finite thing. हमेशा कुछ ना कुछ फाइनाइट वैल्यू होगा हमेशा जब भी आप लिमिट x अप्रोच टू 0. इट विल बी सम फाइनाइट. समटाइम्स इट मे बी 1, समटाइम्स इट मे बी 2, not 2, it can't be 2. It's always like this, less or equal to 1 sin 1 by x less or equal to 1. Okay, it always lies between -1 and +1. This value sin of 1 by x, अगर x 0 की तरफ भी जाए तब भी ये -1 और +1 के दरमियान होगा. बट आई कैन स्टिल से दिस लिमिट डज नॉट एग्जिस्ट. व्हाई? बिकॉज आई नो द वैल्यू ऑफ साइन इट लाइज बिटवीन -1 एंड +1. ओके, लिमिट यूनिक होना चाहिए. सो लिमिट इज नॉट एक्चुअली यूनिक हियर. हाँ, अब बताइए लिमिट यूनिक क्यों नहीं है इसका? You are approaching to 0, okay, either from this direction or this direction, that hardly matters. So you can take these values x equal to 1 by n pi. So this x approach to 0 as n approach to infinity, if and only if n approach to infinity. Okay, is it clear? So if you approach to 0 by this path, by this approach x, by taking x equal to 1 by n pi, then this is same as limit n approach to infinity sin of 1 by x. X is 1 by n pi. Okay, so this is equal to limit n approach to infinity, it is sin of n pi, and sin of n pi is 0, so limit is 0 in that case. But if I take the value of x equal to what, 2 divided by 2n plus 1 times pi, again this x approach to 0 if and only if n approach to infinity, then in that case what's the value of limit n approach to infinity? It's sin of 1 by x, it will be 2n plus 1 divided by 2, or you can say pi by 2 here. It's odd multiple of pi by 2, that's its value is -1 for n. Its value is -1 for n. If I choose so let's choose 4n. Okay, let's do it like this, 4n. So 4n. Okay, So in that case, what's 4n plus 1 times pi by 2? Its value is 1, I think now. For n equal to 0, it's pi by 2, that's 1. For n equal to 1, it will be 5 pi by 2. So 5 pi by 2 is again 1, so it's always equal to 1. So this is limit n approach to infinity of 1, that's equal to 1. So both the approaches, they approach to 0, and both, if you choose this approach or this approach by letting n approach to infinity, both the things will approach to 0, but the value is different. Here it's 0 and here it's 1. So that's why it's not, this limit does not exist. This limit does not exist here. So इसमें अब हमें थर्म एक करनी है, which जो मैंने बता दिया था, अगर f continuous होगी, यूनिफॉर्म continuous होगा किसी डन सबसेट पर, then it will be uniform continuous. Then we can extend it to whole space by and with preserving this uniform continuity, and that we will do in next lecture. Any question?